Hello, Science 9. Welcome to your Q&A for April 6th. You had some questions. Well, a few of you did. Most of you actually didn't fill in the form, which we're going to fix. You got to fill in that check-in form. But some of you had questions, and I have answers. So we'll go through and talk about what you asked and some answers for that. And hopefully this video will help out a few of you. So first of all, I have mixed up ionic and molecular compounds. Well, let me help you unmix that up. So, first of all, the most important thing for us to understand about ionic and molecular is what kind of elements they contain. So, I have the staircase line right here on my periodic table. Yeah, there it is. It looks like a staircase. And to the left, everything is a metal. To the right, everything is a non-metal. So, it's really simple. If anything in the compound is a metal, so if you have anything on the left-hand side of the staircase, and it will be the first element every time. So if the first element is a metal, it's ionic. If the first element is not a metal, it's molecular. That's it. Important to remember that hydrogen is not a metal, even though it's on the left-hand side. So first element is a metal, and for a molecular, it's a non-metal. That's how you tell. That's it. Okay, whether you're looking at the name or the formula or whatever, that is how you're figuring out if it's a metal or a non-metal. So if I have something like lithium oxide, Li2O solid, I take a look and realize, hey, there's lithium. It's on the left-hand side of the staircase line, so that means it's ionic. Well, if I have something like N2O4 liquid, I look and try to find where nitrogen is, and it's to the right of the staircase line, so it's a non-metal, which means that this is molecular. So that's it. I got something like cobalt chloride, CoCl2 solid. Hey, here's cobalt. It's to the left of the staircase line. This is ionic. So that's how you tell. That's it. All right. You just look at the elements it has, the first element specifically, and see if it's a metal or a non-metal. If it's a metal, it is ionic. If it's a non-metal, it is molecular. I'm still confused on the naming and writing of formulas. Well, at this point, the main thing that we focused on is molecular. Molecular compounds are all about prefixes, okay? So prefixes are the thing that we focus on for molecular. Well, for ionic, it's all about charges, making charges equal out, not prefixes. So what do I mean by prefixes? That's the mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So if I have something like SF6 gas, the way that I would name this is I would take a look and realize, okay, I got one sulfur because I have no number there. So I have sulfur. I never put mono on the first element. Then I have 6 fluorines, so that's hexafluoride. And the ending always gets changed to "ide." If I have, like I showed on the last page, N2O4, well, that's dinitrogen. Okay, di, because di means 2. So I have 2 nitrogens, and then I have tetra oxide. Tetra stands for 4, right? So I have 4 oxides. When I'm going the other way, it's really easy, right? Because I just actually use the prefixes to tell how many I have of stuff. So di means I got 2, so I make sure I have a 2 as a subscript number after the thing that I'm talking about. So let's say I have something like, let's go crazy here and say I've got tetra phosphorus octa bromide is the name. So I have then P4, right? Because tetra is 4. So P4, and then I have Br8. Now, when you're doing the formula, just important you put a state on it. I don't care if it's correct right now. I just care that you're trying to put states. And you have solid, liquid, or gas. So let's put solid on that sucker. Why not, right? Good, good. For ionic, we're all about charges. So it's about making the charge equal between the cation, the metal, and the anion. You just look up those charges on your periodic table. The naming is really easy. For the naming, all you have to do is just say the two elements with an "ide" ending on the second one. So if I have something like, let's say, Zn3N2, I'm not using prefixes, right? Ionic is about charges, so all I do is I just say that I have zinc nitride. Notice the lack of prefixes for ionic. So because it has a metal, it's ionic, I don't use prefixes. Now if I've got a name and I'm going to a formula, like let's say I have aluminum oxide, okay, as the name, and I'm writing out the formula. Well, I take a look at my charges and I see that for aluminum, I have a charge of 3 positive, and for oxide, it's 2 negative, right? So I have 3 positive and 2 negative. So that's going to meet up at 6. I need 6 positive in total for charges and 6 negative from the oxides for charge. So in order to get there, I'm going to have 2 aluminums, and I'm going to need to have 3 oxides. Really, this is equivalent to writing out that I have 2 Al3 positives and 3 O2 minuses. And the reason why we actually do this is to make the positive and the negative charges equal in total. So notice I have 3 plus 3 is 6 positive from aluminums, and I have 2 plus 2 plus 2 is 6 negative from oxides. So the positive equals the negative, therefore it works. So I have an ionic compound that works. So Al2O3 solid would be the formula for that. Ionic compounds are always solid for a state. One more, why not? Let's say we have something like potassium nitride. Okay, potassium nitride. So now I take a look at my periodic table and I see the potassium has a charge of 1 positive. Nitride has a charge of 3 negative. So 1 positive, 3 negative. This is going to meet up at 3, right? So I need to get 3 positive from potassium, which means that I need 3 potassiums to make this work. And then I just need 1 nitride to get 3 negative. So it'd be K3N solid. Again, this is equivalent to writing out K positive 3 times. And then I have N with the 3 negative. That's really what I'm saying with this notation, K3N, is that I have 3 potassium ions and 1 nitride ion. Okay, and that balances out the charge. Hopefully that helps. That is very quick and dirty molecular and ionic naming and formulas, but really if you're struggling with this, go through the full videos, try out the examples as I show them, right? And then check once the answers are revealed. That is going to be the biggest thing that people do wrong with these videos, is they don't try out the examples. They just watch and it all seems easy, right? When you're watching, and then you go to try it and you're like, oh, I don't know what I'm doing. Yeah, because you didn't watch the video properly and you didn't pause it and try out the examples. So please, please, I beg you, please use the videos properly. Pause them when I present a question, which I tell you to do, then try the question and then check if you got it right. That will show you where your struggles and misconceptions are before you try to tackle it on a worksheet, which will be much better. It will go more smoothly. All right, third question. I mean just the elements in general and how I'm going to have to remember it. You don't have to remember them. You have a periodic table always when you're doing chemistry. You don't have to memorize the elements. You don't have to know anything really about them because it's all on the periodic table, right? So you've got the actual notation, the symbol for the element, as well as the name and the charges and everything you need just right here. The only thing that you have to know is that metals are on the left of the staircase and non-metals are on the right. Yeah, but I mean, everything's just provided for you. So maybe I'm misunderstanding the question. I very well could be, and if I am, please clarify, and I can answer that in the next Q&A for sure, or get help during Zoom tutorial, any of that jazz. All right. After that, what else do I have? Oh, I thought you'd be interested in seeing from the 13 responses that I had from the check-in form. Yeah, more of you need to do the check-in forms. This is when I grabbed the the image, maybe there is more responses now. But for the most part, people think that the amount of work in Science 9 is about right, so that's great to hear. We did actually kind of lighten the workload later on in the week that you probably noticed, and that will continue. Just making sure that you're not completely overwhelmed with schoolwork, and hopefully it's not taking too much time. It's a mix, right? I want to make it so it's not stressful at home for you trying to get all this done, but I also want to make sure that you're prepared for Science 10 in what you'll learn. So we'll, strike that balance. We'll make it work. But yeah, I'm glad to hear that for the most part, people think that the amount of time needed to do the Science 9 work is okay. Finally, the best chocolate bar is Twix. And I think one of you said that. So good for you. You know your chocolate. The rest of you, be better. Yeah? Eat a Twix. You'll like it. It's the best chocolate bar. End of story. All right, that's it for the Q&A. Last question that probably will come up. Yes, I did cut my own hair. It was really tough trying to do that in the mirror, especially the back. So just took the clippers to it. Way shorter than I intended. It is what it is. All right, you guys enjoy the rest of your day.